Okay, here's problem solving video 3.72. For this circuit, it says find V0 using mesh analysis. Again, we'll rely on the problem solving strategy on page 117. If we look at the circuit here, we can see that we have three meshes. And what we'll do is we're going to assign three mesh currents. Okay, I'm going to assign I1 here, I2 here, and then I3. So if we look at our system, we have three mesh currents, I1, I2, and I3. And so we're going to need to write three equations. And the complicating factor here is that we now have a current source. And remember, when we have a current source with mesh analysis, we have to write a constraint equation for that current source. So one of our equations is going to be the constraint equation. Okay, and so if we look at our current source up there, and we say, well, the current flowing up through here in terms of the mesh currents is I2 minus I1. So our constraint equation then is I2 minus I1 equal 0.002. So there's one of our three equations. Now, we do not apply KVL to any mesh that contains that current source. So if we look, mesh 1 and mesh 2, the current source is a part of those, so we're not going to apply KVL to either one of those. Now we can apply KVL to the third mesh because there's not a current source involved there. So if we do that, so if we do apply KVL to mesh number 3, okay, and let's say we start here, we'll have 3K times I3 minus I1 plus, for this resistor, we'll have 6K times I3 minus I2. Then we'll have plus 6K I3 minus 8 equal to 0. So if we simplify this equation, we'll have minus 3K times I1 minus 6K times I2 plus 15K times I3 equal to 8. There's our second equation. Now we still need one equation. And where we're going to get that is we're going to use a super mesh. Okay, and that's what we do when we do mesh analysis with current sources. So we take this and we can apply KVL to this loop or this loop. So if we look at a super mesh, you can think about removing that and make an open circuit, and that gives us two possibilities. We can go around the outside, okay, or as an alternative, we could come around through that. So there are two possible paths. Now, we started off, we said we only needed three equations. We wrote the constraint equation, we applied KVL to mesh 3. We only need one more equation, so we can get that by going either around the outside, or we can go around this one. So let's do the outside. So let's do KVL on the outside. Okay, so for the outside, we'll have 2K I1, so drop here, 3K I1, so drop here, then we'll have 4K I2, there's a drop here, we'll have minus 12 for this source, okay, for here we'll have 6K times I3 for this one, and then if we come around, we'll have a minus 10 equal to 0. So now let's simplify or collect up some terms here. So now we'll have 5K I1 plus 4K I2 plus 6K I3 equal to 22. So there's our third equation. So now we're ready to solve. We did the constraint equation, we applied KVL to the mesh that didn't contain the current source, and then we did a super mesh, and we decided to use a loop around the outside to get our super mesh equation. So now let's write our equations in matrix form and solve them. So we're going to be solving I1, I2, and I3. Our first equation is the constraint equation that we have in the matrix. And you'll notice now that we don't have a symmetric matrix anymore. Okay, now using MATLAB, here's what we get for the answer. We get I1 is 0.4762 milliamps, I2 is 2.4762, and I3 is 1.619. Now if we check, we know that I2 minus I1 was supposed to equal 2 milliamps, and if you subtract I1 from I2, notice you get to 2 milliamps. Now from our circuit, this time V0 is just 6K times I3. So then for our solution, we have 6K times I3, 6K times 1.619 milliamps, and that gives us 9.714 volts.